This video is going to be the last part of our series on extraneous and confounding variables. In this part of the video, we're going to talk about ways to eliminate confounding variables in an experiment. In an experiment, eliminating confounding variables is crucial because in an experiment, internal validity is what you're after. When a researcher does an experiment, the researcher is hoping to confidently reach a cause and effect conclusion. And to be able to do that, the researcher has to eliminate confounding variables. So first of all, there's random assignment. Random assignment is something we've been talking about all semester. It's a process of randomly assigning people to conditions. If a researcher assigns people to conditions in a non-random way, that might create confounding variables. For example, if a researcher lets participants choose which group to go into, that might create some confounding variables because one condition might attract a certain type of person, and the other condition might attract another type of person. And if that happens, the two groups will be unequal on some type of trait. And that'll end up being a difference between the groups other than the independent variable. And so a researcher wants to do random assignment to ensure that the groups are at least roughly similar to each other on personal traits, on participant extraneous variables. And second, we have control. Control is holding an extraneous variable constant throughout the experiment. It's basically ensuring that an extraneous variable never changes, and it's the same for all participants. So if an experimenter ensures that all participants are 18 years old, then that's controlling age. Or if the experimenter gives each participant 5 minutes to complete the recall test, that's controlling recall time. It's ensuring that it never changes. If the researcher reads the same exact directions to all participants from a script, that's controlling the variable of the directions. You might have been in a university hallway at some point and seen a sign that says, experiment in progress, do not disturb. If you saw that, what the experimenter was trying to do is control noise, the noise level. That experimenter was trying to control the noise level of the lab and ensure that the noise level never changes. Because obviously the experimenter doesn't want some people to be tested with a loud noise in the background, like people talking loudly in the hallway, and other participants being tested in a quiet room, because that'll affect the results. So that's what control is. And control has a couple of limitations, or a couple of weaknesses to it as a strategy. First of all, you don't want to control every variable imaginable, because it turns out that the more variables you control, the less realistic the experiment becomes. The more variables you control, the more artificial and less real life the experiment becomes, and your external validity will go down. You might have remembered how at the beginning of the semester we were talking about how control leads to higher internal validity, but at the same time less realism or less external validity. That's one drawback of control. So as an experimenter, you definitely want to control the variables that are important to control, but you don't want to try to control every variable imaginable. Also, in some cases, a researcher will want to control something, but it'll simply not be possible because of practical reasons. So one good example is hours of sleep in a recall experiment. If I'm doing a memory experiment, I might want to ensure that all of my participants got 8 hours of sleep the night before the experiment, but that's not something I can really control directly, because some people might have difficulty falling asleep, and some people might simply not follow my directions and stay up late anyway. I can't really control that very well as a researcher. Also, I might want to test all of my participants at 9 a.m. at the same time of day, but that might not be possible because of scheduling conflicts. For example, I might have limited lab space, and it turns out that I can only test half of my participants at 9 a.m., and I have to test the other half at a different time of day. If control isn't possible, there's actually a backup plan that can be used in place of control, and it's called balancing. So balancing is when you evenly distribute an extraneous variable across the conditions. Or it's basically when you evenly divide an extraneous variable across your conditions. So if I tested all my participants at 9 a.m., that would be control because I'm holding something constant. It's the same for all participants. But if I tested group 1 half at 9 a.m. and half at 3 p.m., and group 2 also half of them at 9 a.m. and half of them at 3 p.m., I've balanced time of day. So that would be balancing. And when a researcher balances an extraneous variable, the extraneous variable is equal on average. So notice how if I test group 1 half 9 a.m., half 3 p.m., and I test group 2 half 9 a.m., half 3 p.m., the two groups are equal on average because group 1 is being tested at an average of noon, and group 2 is also being tested at an average of noon. So basically, the two groups are both being tested at noon, 12 p.m. on average, which means that the two groups are equal on average, and this time of day is not confounding. It's not a confounding variable because remember I told you that if an extraneous variable is equal between your conditions, it's not confounding, and if it's unequal, that's when it becomes confounding. If an extraneous variable is equal on average, like it is here, then it's not confounding because it technically is equal between the groups. So, so these are just three ways of keeping something. These are just three ways of keeping an extraneous variable equal or equalizing it between your conditions so that it is not a confounding variable. And if you fail to do these things, then you'll end up with an extraneous variable that's unequal between your conditions, and you'll have a confounding variable, which is what you don't want. So before we wrap up, I wanted to mention that all experiments have random assignment because random assignment helps ensure that the groups are roughly similar to each other on things that they bring with them into the experiment, like personal traits, like extroversion, IQ, and even things like hours of sleep. But random assignment alone isn't enough to have an internally valid experiment because you also have to, as a researcher, you also have to treat the two groups equally during your experiment. You have to treat them equally in every way except for the conditions that you're testing. Like I said, if I'm doing a memory experiment and I'm testing the effect of temperature, and one group is in a cold room and one group is in a hot room, I'm going to want to treat the two groups equally in every way, except for the fact that I'm giving one group hot and one group cold. So in order to ensure that I'm treating the groups equally during the experiment, I need I need control or balancing. I need one or the other. So you need random assignment to have groups that are roughly equal from the beginning, and then after that, you need control or balancing to ensure that you treat the two groups equally in every way during your experiment. And so yeah, that's it for this series of videos. If you have any questions, just let me know.